Hello everyone. Today we are going to do chemistry paper 4 extended theory, which is of May-June 2025. The first question of this paper is we have to using numbers only state the percentage of nitrogen etc. in terms of numbers only. Part 1 is the percentage of nitrogen in a clean dry air. If we talk about percentage of nitrogen in a clean dry air, it is about 78%. So the number here will be 78%. The clean dry air nitrogen is 78%. Question number 2, the typical operating temperature of contact process. We know in degrees Celsius we have to given out. We know the operating temperature of contact process 450 degrees Celsius. These are all direct database questions. Number of metals in period 3 of the periodic table. As you can see, the periodic table, the metals in period 3 of the periodic table will be sodium, magnesium and aluminium. The first three elements of the period 3, they will be metals. So it means there will be 3. Answer will be 3 metals. Number of halogens which are gases at room temperature. Now, if we talk about the halogens, then fluorine and chlorine, they are gases. Bromine is liquid and rest all are solids at room temperature. They are soft van der Waals solids. It means the answer is 2, fluorine and chlorine. Typical temperature for the fermentation of aqueous glucose in degrees Celsius. So when we carry out fermentation of aqueous glucose, then the fermentation temperature should be around 25 to 35 degrees Celsius. That should be the temperature. Number of unbranched structural isomers of C4H8, which decolorizes aqueous bromine. C4H8 is butene, and there can be 2 unbranched polymers of butene. One is butene, other is but1ene. Answer will be 2. Next question is number of covalent bonds in one molecule of ethanol. Ethanol is C2H5OH. If I draw the structure of ethanol, if I draw it here, it is 2 carbon and then 3 CH bonds here, 1 CH bond and second CH bond here, and then 1 O and 1 H. It is C2H5OH. Now how many covalent bonds? 1, 2, 3, 4, 5, 6, 7 and 8. 8 covalent bonds are there. 8 will be the answer. Out of that, 5 are CH bonds, 1 is CC bond, 1 is CO bond and 1 OH bond. These are total 8. Next, H part is number of carbon atoms in one molecule of propyl butanoate. It is an ester. We have to form propyl butanoate. For this structure, first you have to draw the structure of ester. For making an ester, you should first draw this C double bond O and single bond O structure, which is we can say the base structure of esters. Now we know this YL group, which is propyl, it is always attached to the oxygen, and propyl means 3 carbon. It means a 3 carbon YL or propyl group will be attached here. Next is butanoate. Butanoate means 4 carbon and OH. Including the carbon of ester, there should be 4 carbon. It means 3 more here. So it is propyl butanoate. This is the structure. Now how many carbon atoms are there? 1, 2, 3, 4, 5, 6, 7. Answer is 7. Okay. Next question is question 2, and this question is about covalent compounds. First part is what is meant by covalent bond. A covalent bond is formed due to mutual sharing of electrons between 2 atoms. These 2 atoms should be non-metallic and they share their electrons. They share the electrons mutually with each other, and this sharing occurs when the nucleus of one atom attracts the valence electron of other. The nucleus of one atom, one atom will attract the electrons of other. The nucleus of one atom will attract the electrons of other and vice versa. Due to this, they will come closer and they will form or overlap and they will form a covalent bond. The definition should contain all these words. What we have to write is bond formed by mutual sharing. Mutual means both will share the electron. Mutual sharing of valence electrons between which type of atom they should be? They should be non-metallic. Between 2 or more non-metallic atoms. 2 or more non-metallic atoms in which nucleus of one atom of one atom attracts, electrostatic force of attraction is there, electrostatically or electrostatic force of attraction, attracts valence electron of other atom, and vice versa, So this should be the complete definition of covalent bond. Mutual sharing of valence electron between two atoms or two or more atoms in which nucleus of one atom, the nucleus of this atom is attracting the electrons of other, nucleus attracting electron of this, and this nucleus attracting electron of this. This is called as electrostatic force of attraction between nucleus and valence electrons. Okay, B part. Chlorine 1 oxide Cl2O is a simple molecule with covalent bonds. State what is meant by 1 in the name of chlorine 1. So whenever we write 1 in Roman numbers, this tells about the oxidation state of valency. So I can say it is valency or oxidation state of chlorine, oxidation state of chlorine, oxidation state of chlorine in the compound. Complete the dot and cross diagram of a molecule of chlorine oxide. Now in this case, Cl2O, that is, there are two chlorine atoms sharing the electron with one oxygen atom. Chlorine outermost shell has 7 electrons. There will be 7 cross with chlorine, 6 and 1, 7. And this chlorine also has 7 electrons. These are 6 and 1, 7. Oxygen will have 6 electrons, 1, 2, 3, 4, 5 and 6. Thus they will share with each other, forming ClO and Cl bond. Clear? Third part is explain in terms of structure and bonding why Cl2O boils at low temperature and does not thermally decompose into Cl2 and O2. Okay? Does not decompose into constituent elements Cl2 and O2. As we know, Cl2O is a covalent molecule, and in covalent molecules they have weak van der Waals forces between them, and due to this weak van der Waals forces it should have low boiling point, thus it should boil at low temperature. The first answer should be Cl2O exists as a simple covalent molecule does have what it have? Weak intermolecular forces or van der Waals forces between molecules, intermolecular forces, or we can say van der Waals forces between the molecules, thus have low boiling point, low BP or boiling point. Okay. The second part says it does not thermally decompose. Thermal decomposition depends on the internal bonding. Now the internal bonding is a covalent bond with a strong bond, hence it will not decompose easily with just heating. What I'll write but. The second part says but the bond between Cl and O, bond between Cl and O, chlorine and oxygen, I can say Cl and O within the molecule are strong. So on heating they do not break, let the bond do not break easily. Hence Cl2O cannot decompose into chlorine and oxygen. Cl2O cannot easily decompose into Cl2 and O2. Okay, that should be the answer. Next, fourth part is give two reasons why Cl2O is a poor conductor of electricity. As we had written earlier in the above question, it is a covalent compound, and these covalent compounds and covalent molecules does not contain any ions, hence cannot conduct current. The first part should be it's a covalent compound, covalent molecule, I can say it's a covalent molecule, hence does not have any ions. any ions for conduction of current. Second part is, along with it, it also does not have any delocalized valence electron like metals. It also does not have any delocalized mobile free valence electrons, which is the characteristic property of metals. Hence also it do not conduct electric current. Okay. Now C part is, carbon and silicon 4 oxides both exist as giant covalent molecules. Yes. Name a giant covalent structure of carbon which conducts current. Now carbon exists in three types of giant covalent structure. One is diamond, second is graphite, and third is fullerenes. Fullerenes, graphite, and diamond. Out of this, graphite has a very good conduction, and graphite is used for making electrodes. Therefore, the answer is graphite. Okay. Identify the particles responsible for the conduction of electricity in the covalent structure of carbon. In graphite, only out of four, only 3 electrons they are paired. That is, one electron is unpaired. This one unpaired valence electron on each carbon in graphite conducts that current. The answer will be unpaired valence electron on each carbon. Third part is, silicon 4 oxide contains silicon atoms and oxygen atoms, and the figure 2.2 given below shows a part of giant covalent structure of silicon oxide. Complete a diagram by adding symbols of each of the 9 atoms shown. Okay. Now in SiO2, we should know each silicon atom is connected to 4 oxygen atoms, and each oxygen atom is connected to 2 silicon atoms. Thus, I will fill this diagram on the basis of this. Each oxygen atom connected to 2 silicon atoms, and each silicon connected to 4. That means there will be a central silicon, and these 4 side tetrahedrally, 1, 2, 3, 4, they will be oxygen atoms. So first part is complete. Now this oxygen connected to one more silicon, so this will be silicon again here, then again silicon, then silicon, and then silicon. So this should be the answer for this structure. Central silicon and then oxygen, then silicon bonds. Now question 3. This question is about electrolysis. Complete the definition of electrolysis by filling the missing words. Electrolysis means electro plus lysis, and it means breaking of a compound by passing electric current. Which type of compound? They could be ionic compound or electrolytes. Therefore, the definition will be the decomposition of compounds. It will be ionic compounds, or I can also say electrolyte compound. But the answer could be both, but mainly it should be ionic. The decomposition of ionic compounds, ionic compounds, the decomposition of ionic compounds when they are in molten state or in aqueous solution. When in molten state or in aqueous condition or aqueous solution, when we pass electric current through them, they will conduct current and dissociates into the respective ions. The answer should be ionic and molten or aqueous solution. Now this is set up for aqueous copper sulfate, that is CuSO4, aqueous copper to sulfate, carried out using apparatus shown in diagram figure 3.3. The electrodes are inert, made up of platinum. Okay. So these are the electrodes. The first is cathode and that is anode. Anode is, in case it is electrolysis. And electrolysis, we use the concept LOAP, LOAP. That is the left side electrode. On that electrode, oxidation takes place, and that is anode, and it is positively charged. So using this concept, I will say this is my anode, positively charged, and this is cathode, negatively charged. Okay, cathodes are negative, anodes are positive. Left is the left side electrode. It is not necessary the electrode should be always on left, but these three are necessary conditions for any electrolysis: oxidation, anode, and positive. Oxidation always takes place on anode, and it is positively charged. Okay, now moving to the next part. What it says? It says, state whether the mass of the cathode increases, decreases, or remains same when platinum electrodes are used. As I am using copper sulfate, this CuSO4 breaks to form Cu2 plus SO4 2 minus ions, and water H2O will break to form H plus OH minus ions. Now, cathode, which is negative, positive ions goes at cathode. What will go as cathode? Cu2 plus go. Instead of hydrogen, Cu2 plus, they have more tendency to lose charge. So Cu2 plus will go, accept electrons, and reduced to copper, which get deposited on the cathode. It means the mass of copper will increase, mass of the cathode will increase due to Cu deposited. Cu will get deposit on it. Clear? Describe the change in appearance if any of the electrolyte when platinum electrodes are used. Now I am using copper sulfate solution, and from that copper ions are converting into copper, that is the concentration of copper ions is decreasing. In this, concentration of Cu2 plus ions are decreasing, and when concentration decreases, thus color of the CuSO4 will fade. Color will become light or it fades. Okay. Describe what is seen at the anode when platinum electrodes are used. Now, out of OH minus and SO4 2 minus, OH minus goes to anode, and what they will form? They will form oxygen gas plus water plus 4 electrons are given out. This is the equation for this. 2H2O and oxygen gas is produced. Okay. What you will see effervescence of oxygen gas. Effervescence of oxygen gas produced at the anode. Write ionic half equation. Ionic half equation I already written. That will be, I will write again. 4OH minus gives you O2 plus 2H2O plus 4 electrons. This is the ionic equation. If I want to write the state, it is aqueous, this is gas, this will be liquid, and these electrons. Or I can also write in terms of H2O. 2H2O gives you O2 plus 4H plus 4 electron. This can also be a part of this answer, but the most appropriate will be the first one, plus 4 electron. That can be also the answer. Next is electrolysis is repeated using copper electrode. Now this same electrolysis is using copper electrode. Earlier we had done by the help of platinum electrode, which were inert. They are not involved in the electrolysis. Now I am doing electrolysis using copper electrodes, and what it is just like refining of copper, which we had already done in our courses, refining of copper. Now when we do refining of copper, what happens? The anode, which is the impure copper, anode is made up of impure copper, the anode goes on decreasing, the mass of anode decreases, and cathode, which will have pure copper, the mass of cathode goes on increasing. Now what is the answer for the part 1? State whether the mass of cathode increases, decreases, or remains same. Again it will increase because of copper deposition. Copper gets deposited. Describe the change in appearance of electrolyte. Now in this case electrolyte is not involved directly. The Cu2 plus ions produced at anode, they goes to cathode through the electrolyte. That is, there will be no involvement or no use of the Cu2 plus ions of copper sulfate. Ions from cathode, anode moving to cathode through the electrolyte without involving the electrolyte solution, without using the electrolyte ions. Hence concentration remains same. No change in concentration of Cu2 plus ions. Thus no change in color. Color blue, color same. It will be blue in color, or very slight change we can also say, but we will write no change. D part is aluminium is extracted from its purified ore by electrolysis. Name this ore of aluminium. And we know the ore of aluminium for electrolysis or for Hall's-Heroult process, which is Hall's process we use for aluminium electrolysis. The ore we use is aluminium oxide, Al2O3, which is bauxite. Name the substance added to this process to reduce the operating temperature. The operating temperatures are greater than 2000 degrees Celsius. In order to reduce the temperature to about 800 degrees Celsius, what we had? We had cryolite, Na3Al(F6), cryolite. What does cryolite do? It decreases the working temperature as well as increases the conductivity or increases the movement of ions through the electrolytic solution. Third part is explain why the anodes need to be continuously replaced during this process. We know the anodes of this process are made up of graphite. Anodes are made up of graphite. Anodes are graphite rods or carbon rods. And these rods, they are gradually used up. Why they will gradually used up? Due to the production of, or due to the reaction with oxygen produced at the anode. As we see, whenever we do electrolysis of Al2O3, it will convert into Al3 plus oxide ions, and at anode, this oxide ion goes and converts into oxygen. That is, they will undergo oxidation and convert into oxygen. Okay. Now, this oxygen gas produced react with the graphite rods and burns them gradually. What I will write, anodes made up of graphite rods, which are gradually used up or burnt. I can also write burnt up due to reaction with oxygen gas produced at anode due to high temperature of electrolysis during electrolysis. Okay, that should be the answer for this question. Question 3. One more thing, for any further help in IGCSE course material as well as for the papers, test papers, series, test series, etc., you can visit this ivijyn.com. Through this website, you will find the courses on IGCSE which contains MCQ question banks on various chapter wise. It is splitted, which called as topic wise MCQ paper 2, then topic wise past papers, practice papers, TPPs, which are the practice papers for many topics in IGCSE, and there's a subjective paper which is paper 4. Along with it, there is a comprehensive course, and this course contains all question banks for paper 2, paper 4, and alternative practicals, along with all TPPs, test papers, and exam style questions. And for these test papers and TTPs, if you do the MCQs, they will be checked at once, and you will get the answers along with your ranks and the grades. Whereas the subjective papers, if you do and upload them, you will receive the checked papers after 48 hours. Within 48 hours, you will receive these checked papers along with the answers and the correct answers as per the IGCSE mark scheme. So I hope this website will be useful for you. If you want, you can go and explore this comprehensive course or any other course which you wish to buy.